And Bista Solutions is into enterprise services. We provide complete end-to-end for our customers, starting from business consulting, understanding your requirement, pain points, and down to implementation of the selected solution, customization which are determined to be a requirement for the customer, and down to maintenance and support after a successful go live. So we cover the entire gamut of enterprise services. So Bista would be a one-stop shop for all your enterprise needs. We also, some of the verticals which we have expertise in is manufacturing. We work a lot with wholesale and distribution customers. We also have done implementations in the telecom sector and are working with companies in the auto parts market. If you need more information, check our website. We have customer testimonials. We have more details on each industry vertical and how we can help you. So we're talking about analytics and big data. So some of our services is we provide a complete life cycle of implementation of BI projects. We leverage the latest and the best technology stack for your requirement for data management and analysis. We apply a strong domain knowledge. So we are very strong in technology, but we are also strong in the business domain. So we know the business of our customers very well. We can relate to it and can apply technology to solve their problem. So, that is what we are proud of. We want to consider ourselves more as a business. So some of our offerings include a mix of proprietary, cloud-based or full-stack BI solution. A lot of the information in the technologies which we implement is on our website. But essentially the goal which we do in business consulting is to find out what is the best tool or the best solution to solve your problem. So that's what we do. We also do data management. As a company, you might have a lot of data which you are wondering how you make sense out of. So we do management with ETL, dashboarding and predictive analytics. So we use your existing resources or is an asset which you have and try to bring efficiency improvements into your company by applying advanced analytic solutions. We can also integrate your existing data with existing applications in big data infrastructure. So you need not go through a painful process of replacing your ERP system or CRM system if you don't desire, or if you already have something but you want to build intelligence on top of what you have. We are there to help you out. We will integrate your application into big data, enable advanced analytics and intelligent solutions in your existing system. So that's what our expertise is in. Moving to the next slide, down below you see some of the technologies which we work with. As you see, a lot of leading edge technologies in the open source Hadoop infrastructure or in proprietary solutions. We choose the best solution which meets your requirement. Now we talk about some of the supply chain challenges, and the first one is as a supply chain professional, these are the challenges which you work with on a day-to-day basis. So we have fill rate targets, right? You want, historically a lot of forecasting has been done, it's very rudimentary. A lot of customers we find are using old algorithms which are not state of the art to do their forecast. And so you need an advanced forecasting solution. You might have a lot of historical data. Some customers have 10, 20 years of data, but you can't figure out the best way of leveraging that historical data to your advantage. a lot of customers are hitting the ceiling with Excel. There are limitations in Excel forecasting, and they're hitting the ceilings. You also have SKU explosion. As your business grows, you have more parts come into the SKU, and it's very difficult to track each and every part using the current tools which you have. Other thing another challenge is demand forecasting. You want accurate forecast to be able to base your decisions on how to stock, when to order, where to put your stock in your inventory network. You need an accurate forecast, and that's always a challenge for customers. You also want to take advantage of patterns, whether they are seasonality, trends, upward trend, downward trend in your historical data, and use advantage of it. So maybe if you have a certain part which peaks in summer, you want to automatically and not rely just on your gut feel and put a number on your forecast, right? So you need seasonality adjustment. You also need customer segmentation. So different customers have different buying patterns. Some customers are sensitive to price, some customers are not. So you want to segment your customers so that you can accurately forecast your demand. Another thing you want is a responsive supply chain. So you've made some decisions, you have a forecast, and now you want to you get in numbers and you see that your fill rates are low, right? So you want to see what are your lost sales if you are tracking it, and model that and try and optimize, change decisions on how to improve your fill rate. So it's part of some of the demand sensing which I'm going to show you, of how you tweak the various parameters in your supply chain to respond to these changes in demand. You also want to optimize your price so that you can, it's more of a margin call, but still you would like to optimize the price to meet the demand. And the next is inventory placement. So if you have a multi-echelon network, where do you place the inventory to fulfill the demand in the most prompt manner? Another one important KPI which you look at is the inventory turns. Yes, you want to have the fill rates high, you want to make sure you're not losing out on sales, but you still want to reduce cost. You still want to improve your inventory turns. There are challenges with lead time variations, and especially in this day and age, with the supply chain, your lead time varies a lot for a supplier. You need some advanced tool to model the lead time and take that into account before you make a purchasing decision. And obviously you want to have a correct stocking decision also. External intelligence is a big thing now with the way big data and the way the data is exploding and the availability of data. You just do not want to rely on the information in your ERP or in your system to make decisions, right? You want to be aware of any supply chain disruptions which are happening. There is Twitter, there is all the social media and all the news and blog posts. You want to take advantage of that and be proactive in responding to any supply chain disruption. You also have a lot of industry data which you might want to take advantage of, but you cannot because it's available separately. You've not figured out any way how to import that in your ERP or your inventory system, and you cannot leverage that. You might have product catalog information which is from external sources which you might want to use for making your supply chain decisions. So these are the challenges which supply chains professionals are facing in this current day and age. So let's talk about the big data advantage. And you hear about big data a lot. You have to cut the clutter and understand what benefit it brings to your organization. So the biggest one is the data volume, right? You have huge data sets these days. It could be that you don't have a huge inventory, huge SKUs, or you don't have a large volume or historical transaction, but still some of the other data, the external data, might be huge, and you want to have inbuilt redundancy. You have fast changing data. data is changing. There is streaming data which you want to take advantage of. You have disparate data sources. So you have data from your ERP system, but then there are these web services, or there is this this blog or portal from where you would wonder, hey, it would be nice if I were to I were notified of this supply chain disruption, which appears as a news article in one of the industry. You would definitely want to leverage that unstructured data which is out there on the internet. Obviously, we talked about this. You would like to use advanced algorithms and not maybe historic. A lot of customers have used historical averaging or very simple modeling for your algorithms, but you would like to take advantage of modeling your chain. Maybe looking at outlier analysis is one which we can talk about. Modeling your outlier demand and see which one is an outlier. There are sophisticated algorithms which takes these into account and come up with a forecast. And obviously you want to be scalable. Scalability is the buzzword these days. You want to be scalable with any algorithm which you use. Then there is network infrastructure. You want to probably want to have it cloud enabled, or you obviously want it at an inexpensive price point. You also want to automate some of the things. So if you are using Excel to do your forecasting or supply chain planning, or maybe even a separate tool from your regular ERP, you would want to automate it, right? And this is where big data brings advantage of automating and scheduling your workflows within your business process. And then we talk about ERP integrations. Obviously, you want to leverage the investment which you have done in your enterprise systems, and you want to build an intelligent layer over it and not necessarily rip it apart. So, I'm moving to next. The question is, do I really need big data for my supply chain? I do not have millions of SKUs. Obviously, if you have millions of SKUs, then big data is the solution. But if you do not have millions of SKUs, and if I don't have so much historical data available, but the answer is, it's not just your operational data. We're talking about data across your partners, across the business ecosystem, including information about your customers. Right? So big data definitely has a place for in your supply chain solution. It enables you to quickly deploy structured and unstructured data across multiple systems and social platforms. And it improves your response to the variability in demand or supply chain risk with real-time access to data. And it is obviously a central repository which is one version of truth across the enterprise. So even if you don't have a large volume of data, big data can still help. It can build what we always say as an intelligence layer above your ERP system. So that's why we feel you should still look at big data and see if it can help you in your supply chain. So big data, you hear about these terms, and you hear about 3 V's, or some people call it 4 V's. But it's all about volume of data, the velocity, and the variability, right? So when we say volume, we talk about huge data from different sources. It could be sensor data, your RFID data, and so on. It could be structured data from your operational systems like ERP or supply chain management software, CRM, and so on. It could also be unstructured data from social media, from channels, industry sources, your customer service blog posts, from your customer service requests, warranty data. A lot of data which is unstructured is also part of the big data infrastructure. And the variability in data, you have different data types. It's not just text data. You might want to use video, voice, images, and so on. So this is what big data brings as an advantage to your organization. So we just want to look at the big picture of how supply chain and big data work together. Three parts in this process. The first one is the strategic planning. The second one is tactical, and the third one is real time. So strategic is more about understanding your demand, your performance, and how your data, how your inventory is working. So you would probably do that on a quarterly or a monthly basis to baseline the different parameters so that you can make decisions. The tactical plan is something which you would run on a monthly or weekly basis. So this might include forecasting the demand and running the purchase orders and running inventory transfers. Depending on the type of business you are in, you might do it on a monthly or a weekly basis. And the real time is what you would do on a daily or hourly basis, depending on, again, on your business. So this would be essentially responding to events happening in real time. So maybe you forecasted something and the sale came out to be lower. So what do? Or maybe there is a demand spike in some other location, whereas you have forecasted in some other location, and you want to move from this location to the other to take care of that demand variability. So this is the real-time plan and the part of what we say as demand sensing solutions, which is out there. So the first part, which is the strategic plan, is what we call as the exploration and analysis. So we use multiple models and multiple systems to do an exploration and analysis of your data. We do an FNS analysis to segment your inventory. We do a price sensitivity analysis to see if the demand is sensitive to your price. We obviously look at the trend and seasonality, take out each component of your demand and try to find the trend and seasonality. We also do customer segmentation. Your demand is varies by customer segment, how different customer segment place their orders, are they sensitive to price, do they have seasonality, and so on. We do outlier detection. So if maybe you had a spike, maybe there was some seasonal variation, or maybe you had a promotion event going on, or some other event which caused a spike in the demand historically, and you want to model it out. It was a one-time event, it was a business situation which you don't want to predict. So you want to do outlier modeling and remove the demand which is exceptional and not part of your regular business process in doing it. Obviously, we talked about lead time modeling. Each supplier has their own lead time. We've come across companies who have just used their gut feel or historical experience and put a number on lead time. But we feel it's a very important parameter. You need to find out, model each supplier, each category of product for that supplier, and see how long it takes for that supplier to fulfill that PO, and does it have any seasonality. Maybe whenever you order in the summer, the supplier is always out of stock and is always on back order, right? So which means your delivery gets delayed. But maybe in winters, his delivery time reduces. So you want to take all that information which you already have in your system into account before you make a buying decision. We also do multivariate clustering, which is, we try to use all these parameters and try to group your inventory into clusters so you can define an appropriate strategy for clusters. For parts or products which have similar behavior, so there are tools which automatically define these clusters and let you do the, let you handle them. So once we're done with the strategic planning, what we do is the tactical forecasting. Tactical plan, which includes basically your forecast. So this is it consists of your demand forecast. So using all the analysis which we did prior to this, we would calculate the demand forecast, and we will also calculate the purchase plan. What do you need to buy? When do you need to buy? In how much quantity you need to buy? We also do some of the stock calculations and set the stock parameters of what is your min and max, how much safety stock you should carry, and so on. So based on the strategic forecasting, strategic plan, we come up with a tactical plan. We also make the transfer plan. So this is how you stock inventory. If you have a multi-location, if you are a retailer across multiple locations, you can have a transfer plan for that. And so the strategic plan is reviewed. It can be reviewed quarterly or monthly based on how frequently your parameters, your business change. And this plan can be made monthly or weekly. Mostly purchasing decisions are made with that frequency, but it can also be done on a daily basis if your supply chain is accustomed to that. Then is the real-time operational decisions. We talked about lost sales. We talked about supplier delays. We talked about pricing and external factors. So when you have when these events occur, you want to be able to monitor what you predicted, what you planned for versus what is the actual performance, and make adjustments in real time. Next procurement run or the next time you're placing a purchase order to respond to them. So you want quick real-time decisions. So now with this, I would like to have a demo of, this is a sample consumer retail firm with stores in 15 locations across the US. They sell products in various categories. So think about a retail store spread across locations geographically, selling things from technology to office supply, furniture. So different categories having completely different demand cycles and completely different supply chains. And we would like to know, what do you need to buy for this so that, we don't overstock or we don't understock. As we said, get a balance between how much, between fulfilling demand and having dead inventory in your warehouse. So that the sales, purchase, and inventory data has been brought into Hadoop, and we will see that shortly. And we will see how we analyze the purchase, sales, lost sales, on-hand inventory, orders on PO, safety stock levels, min-max, and lead time. So we will look at this in our demo section. So let me move on to the demo for this. So what you see here is basically our supply chain sample demo, which we talked about for a multi-location retail distributor. So since we're talking about big data, we thought it's worth giving a sneak peek into some of the technical details. If you are not technical, don't worry about it. But this is the big data infrastructure which we use. We use a tool called Uzi, which is a workflow and scheduling tool within big data, and we use that to ingest data from different systems into our big data infrastructure. Right? Obviously, there are other tools like Flume and Scoop, which is all scheduled with Uzi is like a layer on top of them and helps you schedule this. Don't worry about the data. I'm just giving you a sneak peek, but this is just a sample of how we are doing something. This is an integration with a customer whose customer's ERP. So we start this. There is a scoop tool which runs and it imports the data from the customer's ERP, SQL-based ERP system into big data infrastructure. It has, next we do some transformation logic and perform actions on it. So we can basically prepare the data so that we can do the next part of analysis. Once the analysis is done, we do an export, and this is done automatically and into the ERP of the customer. So you see this is completely automated, and this happens in a periodic manner. Let me also quickly show you about some of the background big data infrastructure. Again, this is our technical details. If you don't understand, do not worry. But this is just to show you that this Hadoop has actually become the de facto ETL tool. It's very efficient at it. And once we get data from your structured database, we store it in a format which is useful for analytics. So maybe you have data in your ERP system as SQL table, all data dumped into one table. But when we get it here, we kind of structure it into different folders for different seasons and so on, so that we can quickly do analysis, and these tools are able to get and tweak the data in a manner. So this is just the storage. These are some of our, some of the tools which run in the background in the big data infrastructure. This is one complicated transformation job. We look at, various tables system. We have MapReduce jobs running, and combining and merging this data in a manner which can be used by our analytic software downstream. So this is the ETL pipeline of getting data from your ERP and shoving it into a big data infrastructure, and then analyzing it, transforming it so that further analysis can be done. So this was just a peek insight into the big data structure. I will not get any technical anymore in this webinar. So this is some of the sales data. So this is once we have got data from different parts, we normalize it, and we have this available in a format which we can work with. So this is your sales data. This is your historical purchase data, which we received from your ERP system. Obviously, in forecasting, the purchase data is used for modeling the lead times and the supplier, how well your supplier is performing. And this is just the master data of the different products which you have. So these are the main data elements which we use for analysis. Again, we take it from your ERP system, might have it in multiple places. We take it, we consolidate it, put it in one place so that we can work with it. Once we have the data, we go through this analysis, which is the strategic forecasting we talked about. The tool automatically does an FNS analysis. So we move, we put the categorize your different products into fast, normal, and slow. Now this is used downstream. This is used downstream in the clustering and best fit analysis. So based on the demand pattern and demand frequency of how much basically is being ordered and how frequently, we are able to deal with different demand in different manner. Then we do something called a summary analysis just to see what your data is about. So we see that show me the different quantities of your data, or show me by sales and customize it and show me what is these are the box plots. So these gives you the statistical details about your data. So you see how far it is spread right? So this is, and you see the difference between this, the minimum, maximum, and medium, and the tool automatically does this, and basically, it presents this information to you, but it doesn't need to have human intervention. This data is just presented for analytics and so on, but the summary and the outlier analytics is automatically fed into the system. So the next step is essentially the trend and seasonality. So we try to find the trend in your demand. So basically we see by sales how your demand, how it's trending, or by sales what is the trend for your different categories. We see by category, we see the demand by location, we see if there is any trend or any particular seasonality with regards to your location. We also see order type, and and this is again depending on your type of business. You might have different orders. It could be direct orders, drop ship orders. They might have a different pattern, and it could be any. It depends on your business. Actually, the tool is smart enough. We don't need to know the different order types. If you give us that this is my order type field, it will automatically cluster and find if a certain order type has a pattern and it needs to be forecasted separately. So this is the visualization. Again, let me reiterate. It is basically automated. Our tool automatically finds the trends, patterns, and if anything related to a certain location or a category of product, or if for a particular customer segment, if you have a pattern, it will automatically define it. So I can actually select and see how my demand varies between California and say and Nevada for this particular location, by category of products, and I can find that information out. So this again, our tool automatically finds these patterns. It takes all the combinations in the current. This is the reason why you need big data infrastructure. It is basically automated way. It removes the manual process in the forecasting. You are doing Excel, you are doing by categories, but you need an automated tool to detect all the different patterns in your data and forecast accordingly. Once we've done these analysis, we create what we call as clusters. So this is just a tree map of of the different parts in the cluster. So this is each cluster consists of parts which have a certain pattern. So there might be taking all the parameters into account, the trend, the customer type, the seasonality, outliers, the different locations, category, segments, order types. We group all of them into similar cluster so that they can be treated in a similar fashion. Once we've done that, we come up with a best fit algorithm. Our tool tries various models, right? And it tries and sees which model can be used to forecast the demand for that particular cluster. So we see that for this category and this subcategory, Holt Winter is probably a better model. But if we see furniture and chairs, exponential smoothing is probably a better forecasting model to use. So the tool will automatically detect which is the best model to use to forecast your demand. So if you see tables, again you see that there is it finds the best model. Again, we see Holt Winter apparently is better to model this particular subcategory, and and so on. So the tool automatically determines which is the best model, and based on that, it comes up with a forecast each part for the current period. Right now, we've just done a monthly period for this particular customer, but it will forecast how much your demand is going to be. Right, so you see copiers, and it comes up with the actual demand, the fitted demand, and the forecast. So yeah, so basically what this is this was the actual, and then once we determine the best model, we see we try to split the data up into training and test data set. So once we have trained the model on a data set, we run it on the test data set and see how accurate we are. Right? So this is the accuracy which we are able to determine, and then we forecast. Obviously, for this demo, we just used data until December 2015. But as you have data, you can forecast for the next few months and so on. So this is again another category and subcategory where you can see what is the demand and the different methods, and the best method, what is the forecast with that method. So that's what. So if you see between Jan and Feb, there is a very strong seasonality. It always goes down. So the model actually does it very well. It's learning that yes, the demand is going to go down between Jan and Feb. It's historically done that, so it models that very well. So this is the part of strategic planning. Now we come to the tactical planning, which is the actual forecast. So this, once we've run this, it gives us the forecast by different periods. Now we've set for this customer as a monthly period, but you can define that you want to plan and forecast on a weekly basis or on a daily basis, or maybe you do on a quarterly basis. So that is completely configurable, and what we do is we get the demand forecast for each category, each type of product, and so on. From that, we create a purchase plan. So this tells you, which supplier to buy from and how much quantity you should buy, right? And then it's smart enough to group the orders by supplier and by expected date of order. So this we come up with a purchase plan. Now, as you saw in the workflow diagram I showed, this can be integrated directly to your ERP. So you can either export it as an Excel file and evaluate it and then import it, or we can actually create these purchase orders in your ERP where you can review and finalize it. We also have the stocking plan. So for this customer, which is basically multi-location, we tell them which inventory needs to be on on what level, and we also come up with the suggested min-max. So these are not fixed, these are calculated. So the safety stock, the min-max for that particular location, and our demand and other things are calculated for each and every part and each and every location. And this is again the stock transfer plan of which we'll talk about a little later. So once we've done with the tactical part, where you've placed the orders to your suppliers and you've received, and your sales is running, you have this, which is demand sensing, which we do on a more regular basis, and this is the feedback loop in your supply chain, right? So you see that this was your actual, and you actually forecasted 669 at that location for that part or that product, and your actual was 628. So there is a gap. So the tool automatically detects what is the difference between your forecasted and your actual demand, and it lets you make some decisions on it. So what we do is we call as a lost sale analysis. Your tool is capable of logging lost sales, whether you have an e-commerce website and you are able to log the people abandoned carts, which is, people searched for something, it was out of stock, so you did not get the order. Or if you are in a B2B where your customer service agents are taking orders and they are logging lost sales, we can take that data and see and try to model the lost sales and evaluate what is happening. The delays in shipment. So as the supplier ships, we are able to see what is the actual lead time and what is the average lead time across different suppliers and for different product lines. So we do that, modeling of shipment delays by vendors as and when they happen. So you see different suppliers with different product lines have different performance levels. Now what you can do is, once you have this, what we suggest is pricing adjustment and inventory leveling. So based on if you are losing out on sales, you might want to go and evaluate, and this tool will model if, say, you change your price, decrease it by 5%, what would be your actual demand? So it tries to model, create a correlation between the price and the demand historically, and tries to predict if you change the price because your competitor has either changed the price or you're losing, your sale was actually lower than expected, and if you reduce by 5%, what would be the percent change in demand, right? So now these are very price sensitive items. So you see, a 5% change actually has a huge change in the demand. So, and you can do it for different categories and subcategories, and this is what the tool does. It creates a correlation between your price and your demand, and you can model it for each category and each subcategory. The next is inventory leveling. So you have, based on the forecast and the purchase plan and the stocking plan, you did a forecast. You placed inventory in different parts in your different locations, but you might want to move, because suddenly there is a spike in demand in Florida. So you might want to move these many quantities from New York to Florida because they are excess in quantity. So the tool automatically finds and does an inventory planning and leveling for you. So this is the complete cycle of the tool. If you have any questions, feel free to contact us. So in conclusion, we've seen that data science and big data enables automation of your supply chain process. We've seen that the machine learning tools in Hadoop, and I've not shown Spark, but that is what we use, can be used to build very advanced analytical models. We've seen that big data enables us to work with very large data sets and structured and unstructured data. We use advanced exploration and clustering techniques using big data, and using which we can accurately forecast your demand, model your supplier lead time, model your outliers, price sensitivity of your demand, and so on. We do strategic forecasting to calculate procurement and inventory requirements, and then we make real-time decisions based on the forecast. So with that, I would like to open up for Q&A. So if you have any questions, you can write down, there is a chat window in GoToWebinar. You can write your questions in that webinar. So we have a question. Our system gives us on-hand quantity. However, they are reported at a specific moment and doesn't store any historic on-hand quantity. How do I solve this problem with big data? Because of this, we are not able to analyze historic performance. So yes, this we come across a lot in with our customers. Your tool, ERP tool, does not maintain history of how much stock you had at a certain point of time in past. So if you want to model and see your KPIs and how they have been improving, it gets really difficult. It just tells you this is how much you have right now. So the solution for that is, we have to basically backtrack. It really depends on what the ERP gives us. We can write, and we work with our customers, we can backtrack and calculate how much you had 1 month back based on the sales and the receiving. Based on the shipments and receiving, we kind of go back in history and try to recreate how much data you had 1 month back, or how much stock you had 2 months, 6 months back, 1 year back, and so on. So we try to do that. It is not a trivial thing to do. It is definitely challenging, and but we've done that for some of our customers. Okay, so another question is, how do we take care of intermittent demands, especially for slow-moving products? How do we make sure that we do not overstock these products? So yes, intermittent demand or slow-moving products, and it really depends from customer to customer. I've had customer who said, if I sell more than once in 2 years, I don't consider it as slow. So you have, especially with people who are stocking spare parts, that is a very big challenge for them, and it is a modeling challenge. We have used some very advanced models and very advanced research done on modeling slow-moving parts. We've used bootstrapping method or Croston models to predict slow-moving parts, but they definitely need special handling. It is complicated, to say the least, to accurately forecast your slow-moving parts. But yes, we can work with you on it. Obviously, it needs a lot more business insight to model it the first time. And once we have it, it can run automatically and update the inventory. So if anyone has any more questions. So we have another question. It says, can I track inventory movement real time with big data, and how? So I guess it's kind of related to the earlier question, I assume. So yes, you want to model, your tool is just giving you current on hand, and you cannot have your inventory KPIs to accurately calculate your inventory turns or other KPIs. And yes, if we can work with you, we can see the transfers and calculate inventory as of point in time. So you can do a point in time analysis and see where your inventory is headed. So I guess if there are any more questions, feel free to contact us. I have our numbers on the screen. Email us or call us, and we will be happy to talk to you on how big data can help solve your supply chain problems. Again, thanks for everyone for attending the webinar, and have a good day. Bye.